Amean and I will talk about Saturn Treasury, which is the component of Saturn responsible for setting up the incentives and defining the payouts to the node operators. I'll start with an introduction to the design and how we ended up with such a design, and then Amean will pick up and talk about the implementation. But before going deeper into the design, I want to discuss a little bit about the value flow within Saturn, so we are all on the same page and the design choices are a bit clearer. So first, we have the content publishers. These are essentially websites or services that want to serve content stored on Filecoin. And they engage with Saturn to get their content accelerated. And so they will pay Saturn for this service. Then we have the users. So end users are normal people, everyone here. They are just going to these websites and to this service, and they want to receive this content fast. And so they engage with Saturn by submitting requests for specific content, and Saturn will route that request back to them. They may have any sort of financial relationships with the content publishers, such as ad revenue or subscription models, but this will be completely independent of Saturn. Okay? And then we have the final piece of the puzzle, which is the node operators. These are the servers that are committing resources to the CDN. And so every time there's a request to Saturn, these nodes will serve that request back, and in turn will receive some Filecoin. Important point that I want to stress out here is that the nodes will be paid based on their own logs, so the information they are submitting to the orchestrator. And this means that we have an attack vector here where we can have nodes lying about their logs. So they can doctor the logs, they can fake traffic, and this is a fact that guided a lot of the final design choice. And because of this, we have to have this module, which is a fraud detection module in place that is essentially trying to flag and catch this type of behavior. So these type of logs or nodes that are faking traffic or changing and doctoring their own logs. And then we have the reward calculator. This module is essentially responsible for gathering all the statistics, the performance metrics, and the flags coming from the fraud detection system, and defining the final rewards and payouts to the node operators. And then at the end, we have the monitoring. So the monitoring piece is collecting statistics out of the fraud detection and the reward calculation. And the goal here is to have an iterative process where we can keep improving on the whole system as we move forward. Now, when we talk about incentives, a first important step is always to think about what behaviors we want to see in the network. And this means thinking about what good behaviors we want to incentivize and what bad behaviors we want to avoid. On the side of the good behaviors, we have three. The first is a high bandwidth service. So this means that we want the network as a whole to serve as much content as possible. The more content we serve, the most content publishers we can engage, and the more users we can serve. So this is one of the key performance metrics we are targeting. But at the end, we want speed, right? If a content goes to a website and doesn't have the content fast, the user experience won't be good. And so speed is also another behavior that we are targeting. And here we use two main metrics. The first is the time to first byte, and the second is the total download time. And finally, we have the reliability. So we don't want nodes going offline and leaving users without their content. And so uptime is another metric that we care about. Then on the side of the bad behaviors, these are essentially those behaviors I described before. So nodes doctoring their own logs, faking traffic in order to get a bigger share of rewards. From these two sets of behaviors, we have these two questions that we'll try to answer in this presentation. The first is, based on the performance metrics we define, how can we better distribute rewards? And secondly, how much should we penalize nodes in case of bad behaviors? So how much do we define penalties so that nodes are incentivized to behave in that way? So on the side of the rewards, we ended up using this sort of concept of service scoring functions. These are functions that map specific service metrics, such as bandwidth, uptime, all those metrics I've discussed before, into a ratio of rewards. And why a ratio? The reason is at each payout window, we will have a fixed amount of fill that will be distributing for the nodes that participated during that payment window. And so we need to get the metrics of performance of those nodes during that window and transform that into a share of rewards. And here we have an example for the bandwidth, but the final function is the same for all the metrics. So we ended up using adjusted version of a share of performance. And it's adjusted because it's using this exponent k that is essentially controlling how much we reward over performers, okay? To make it more concrete, an example would be using a linear function, and this means using a k equal to 1, and essentially here we are rewarding proportionally on the performance. So a node serving 40% of the bandwidth would receive exactly 40% of rewards. And the more rewards, the more performance you have, the proportionally more rewards you get at the end. But we could also have a coefficient that is higher than 1. And here we have an example for a quadratic function, so k equal to 2. And in this case, we are rewarding more the overperformance. So as an example here, the same node committing the same 40% of bandwidth would receive almost 90% of rewards. And on the other hand, if the k is less than 1, then this means that we are distributing rewards more evenly among the nodes. And so for a square root function or a k equal to 0.5, the same node that is serving 40% of the bandwidth would get around 15% of rewards. So we got all these functions and all these possible values for k's, and we did a full simulation of how this would play out with different types of nodes. And we ended up with this final proposal. So we are still using those three behaviors I discussed before: bandwidth, speed, and uptime. And then we have different coefficients for some of them. So for bandwidth, we have a square root, so a k equal to 0.5. And for speed and uptime, we have a quadratic function, so k equal to 2. And the reason for this is that on the bandwidth, we are distributing rewards more evenly, so everybody is coming together and sharing the load. But at the same time, we are penalizing in a meaningful way the operators that don't perform at the level we want in terms of uptime and speed. Now, for the penalties, so when we were thinking about penalties, we thought about a way to define some sort of theoretical bounds for these penalties. And for this, we started with two assumptions. So the first assumption led to a lower bound on the penalty. And this assumption essentially says that the penalty needs to be large enough so it's not economically advantageous to cheat, okay? What does this mean? So we have a fraud detection system in place. This fraud detection system will never be perfect, so sometimes it will have some node that is cheating and it won't cache it, okay? And so this probability of a cheating node being cached is also known as the true positive rate of the system, and we can use this probability to build this equation where what we are essentially saying is that on the long run, such a node that is consistently cheating the network will sometimes be caught, other times will pass through, but on the long run, the overall rewards need to be negative. Okay, so on the long run, this node is not incentivized to participate. And if you solve this equation, you get that the penalty depends on the true positive rate of the system, and also, which is nice, the average reward before penalties. So you can actually compute this lower bound for each node. And then for the upper bound assumption, now we focus on the honest nodes. And here we are saying that the penalties need to be small enough so we are not hurting these nodes too much. And so again, the fraud detection system is not perfect. Sometimes an honest node will be flagged. And this probability of an honest node being flagged is also known as the false positive rate of the system. And what we are saying is that on the long run, these nodes should receive at least a certain ratio of rewards before penalties. And this ratio is this tau here that we are encoding. And if we solve this equation, then we get that the penalty has an upper bound or needs to be smaller than a constant that depends on the tau and the false positive rate of the system, and also, again, the average rewards before penalties. And once again, this gave us an interval of some possible values for penalties we could use. We run some simulations, and we settle on these 5-time multipliers. So this means that if you are flagged by the detection system, your penalty will be 5 times your average long-running rewards. Okay? And this, again, reaches a balance between guaranteeing that cheating nodes don't extract too much value, while at the same time making sure that the honest operators are not overly penalized. And now I pass the mic to Amean. We'll talk about implementation. Thank you, Amean.
Hello, everyone. My name is Amean, and I'm one of the engineers on the Filecoin Saturn team. And over the past few months, I've been working really hard to turn Maria's reward design functions into a working live payments implementation. And Maria showed you the value, and I'm here to show you the money. First, I want to start by describing all the moving pieces that are part of Saturn payments. And the idea here is to get a fine grasp of the data flow that has to happen before a payment is made. I know this is a big diagram, and what I'm going to try to do here is break each component piece by piece and explain what it actually does. So to start, the Saturn payments pipeline officially starts at the retrieval clients and L1 nodes. And hopefully this interaction is already familiar to the audience from the previous presentations. But just to recap, what happens here is retrieval clients send retrieval requests to L1 nodes. L1 nodes send files to these retrieval clients. And as a result of that transaction, 2 important things happen. Now these L1 nodes, well, the first thing is now these L1 nodes are owed money. So how do we pay them? Well, as it happens, I know the answer to that question. And the second thing that happens is there's data generated from that transaction. So what do we do with that data, and how does that data factor into computing payments? And the first part of the answer to that question is the log processor. So the job of the log processor is that it ingests all the data from transactions between L1 nodes and retrieval clients. And what it does essentially is that it extracts meaningful information from it. An example of this information includes time to first byte, the time for the request to be served, the download speed, etc. It's essentially trying to quantify an L1 node performance while serving files. And it formats that data and stores it in our Saturn storage. Now, the second part of the answer to that question is the orchestrator. Now, Diego introduced the orchestrator, and it's one of the core components of Saturn. And in the context of payments, what the orchestrator is doing is that it's keeping track of active L1 nodes and performing health checks on them. And from these health checks, we can get an adequate estimate of a node's availability and uptime. And with that, we have 2 key pieces of information. From the log processor, we have node performance. From the orchestrator, we have node uptime and reliability. And with that, we finally have the required metrics that enables us to use the reward functions that Maria just described to process payments. And with that, we can finally introduce the Saturn treasury, and the job of the Saturn treasury is very simple. It ingests all that data, computes fraud, computes payouts, and issues those payouts to L1 nodes. So I'm going to try and break down this architecture a little bit more. So the data flow, just to recap, the data flow in the Saturn treasury is that you receive all the transactions from these logs, you detect fraud, you calculate payments, and all of that is being monitored, and then you issue those payments. So this essentially breaks down to two serverless functions that we run, a payments aggregator and a payments issuer. The job of the payments aggregator is that it runs very frequently, currently every 30 minutes. And what it does is that it collects key payment metrics and calculates aggregate payments for L1 nodes for that period. A good analogy here is that you can think of the payment aggregator as sort of a bookkeeper that patrols the network frequently, observes the state, and makes payment calculations based on that state. Now, the second function is the payment issuer, and that runs every month. And the job of that function is to simply sum up all the payouts, update penalties, and issue those payouts to nodes. And another useful analogy here is that you can think of the payment issuer as an accountant that looks over the logbook at the end of the month, sums everything up, stamps it, and sends it over for payments. And the reason we have an aggregator and an issuer is for two things. First of all, the aggregator gives us a lot of visibility and monitoring over key payment metrics and allows us to generate data that we can use to improve that pipeline. And the second thing is decoupling payment calculation and payment issuing allows us to change one of those components without impacting the other. So the final breakdown here is the final breakdown of payments. I want to walk you through the logic of what's happening as logs are processed through these functions. So just to recap, everything goes to the payment aggregator first. So the payment aggregator processes all logs. First thing it does is that it computes fraud on the network based on our fraud detection model. If fraud is detected, we flag logs, and then penalties are computed for the nodes that are responsible for these fraudulent logs. And then it assigns reward scores for nodes. These reward scores are assigned per the functions that Maria was just discussing. And finally, it computes fill earnings and fill penalties based on the reward scores and the fraud that we just detected. And it stores all that information in our Saturn storage. And then at the end of the month, the payments issuer run. Again, it's like our accountant here, and it essentially retrieves all the stuff that we just stored from the payments aggregator, retrieves the penalties and the payment aggregates. It computes the final node earnings for that month, and it updates a global penalty value. And the reason why I have a global penalty value is to keep track of fraud if it accumulates on the network. So if you commit fraud a lot, Saturn will not forget. And as you may have guessed it, we also store that information. So I want to walk through a little bit of what the next steps for Saturn payments are. And as Maria mentioned, the design is going to evolve. The way we design payments is something we want to iterate on a lot to improve, and accordingly, the implementation must change. So the first two things or the first substantial things that we want to look at is moving towards decentralization. As you may have noticed, payments is not currently a decentralized service. That is not a bug, but merely a temporary feature that we have. But yeah, we're looking to change that. And the second thing is enable some form of learning in our pipeline. And by learning here, I mean that we, as you may have noticed, we store a lot of data. We extract all the useful metrics. We ought to use that data and feed it back into our system, do some form of analysis, and use that to improve our mechanisms. A great example of learning is implementing like a machine learning-based fraud detection model. That would be like a great example of implementing learning in our pipeline. So I want to go over what that looks like on the network. So this is currently our current setup. We have retrieval clients on one side, L1 nodes, and we have the transactions going between them. And then retrieval clients submit all the data to Saturn Treasury. Saturn Treasury it invokes the serverless functions to compute everything, and then it pays the L1 nodes. And this is kind of what we want it to look like. So we want the network of nodes to communicate with each other. We want the network to invoke its own payment function to compute what payments will be for each node and issues those. As you see, there's one lonely node there, but I just wanted to be realistic. And the final thing here is describing how we're going to move towards learning, and it's a very simple step. This is what we have for our pipeline now: retrieval logs, detecting fraud, payments calculation, and then issuing those payments. And implementing a feedback loop is as simple as that. And it's simply feeding back, taking that output, feeding it back, analyzing it, and using that analysis to improve our mechanisms. And the beauty of the feedback loop is it's one of those simple engineering features that have yielded remarkable engineering results. The feedback loop has enabled, it's really like the fundamental feature that feels like machine learning is built on. The feedback loop has also quite literally guided our spaceships to space, and Saturn is nothing short of that. And with that, I'd like to officially conclude our Saturn launch. I'd like to invite Maria back to the stage for questions. Here's our contact information. If you have any questions, you can reach out to us. And yeah, open for the questions.
Yeah, so my question is, when you detect fraudulent behavior in the network, why do you just like reduce the payment a little bit? Why don't you slash it to 0 or ban those nodes permanently or start legal action?
Yeah, so the idea behind the penalties is not that you will slash a little bit, you slash 5 times the average reward. And so you could implement this in 2 ways. You could either ask for a collateral, this is how Filecoin does it, but we wanted to make onboarding new nodes, at least at the start, as smooth as possible and to eliminate as much barriers as possible. So the way we are doing it is kind of adding a buffer window. So at the start, nodes will not earn any rewards while they are accumulating enough past rewards to account for future penalties. And then once that buffer is built, they will start getting paid. And so what we expect is a cheating node will get flagged, and so will never reach, or will reach very unlikely that point where a payment would be made. Of course, we can then think about if this guy is being flagged all the time, maybe it should be kicked out. It's true, but just once, sometimes it will happen. Like we expect a fraud detection system to sometimes flag honest nodes, and just because you're flagged once, you shouldn't be kicked out as well.
Self-dealing seems like a bit of an impossible thing to detect properly. Can you talk a bit about how you're going about detecting self-dealing? Yeah,
so in this case, it will be a hard problem. So at this point, we are essentially trying to eliminate what I like to think of the dumb fraud. It's like, if you are clearly self-dealing, it's easy to flag. Then we can start thinking about, okay, maybe you can hide and switch your IPs, and it will be very hard to catch. But in the end, so the way I see it is that we have clients that will be onboarded, and they will have their own fraud detection system in place as well. Like you have DDoS attacks, protection, and all these things. And so we will also lean on that and try to make sure that we are just not, so that we are catching more like fake traffic in a sense that will not be realized on the side of the client. So what I mean by this is if the client would be happy to pay for that self-dealing. So imagine I'm a node and I'm visiting a website and I'm paying for visiting that website, then that's not really self-dealing, right? So that's what I mean. Sorry, it was a bit confusing. Did it answer your question? Yeah, okay.
Sorry.
Yeah, go for it.
I had a question on that diagram. You had the retrieval client and the L1 node both reporting to the orchestrator. When Ansgar demoed earlier, it looked like he was using curl. How does the actual, how does the retrieval client report? I guess if you have a service worker, they could, but like if the URL is available without it, what happens?
Might be a question for Ansgar.
Yeah. Oh, we're just going to hug it out.
Okay.
So great question. The short of it is, for traffic that we want to take from the IPS gateway, that's traffic like that will serve curl, where curl is kind of, it can't verify the content it receives. And so we will run and we'll have a subset of nodes, which are like trusted nodes. And these will resolve, these for like the dumb clients, they'll use that. But for websites and any other clients, like have a service worker, run a website, run a game, have kind of our retrieval client that can do verification, they'll have full access to any node in the network. And so these clients, the dumb ones like curl that would hit some of these nodes, they're more trusted, we trust those logs. So we don't need to say corroborate the 2 logs.
Oh, so if I'm using curl, I don't get the whole network. I just
Right,
get
right.
some small subset. Got it. And does the small subset get paid, or because they're completely trusted, essentially?
Right now, it's trusted, and
Yeah.
we want to work with other tools like this to,
Yeah.
expand the network that they would touch. But of
Okay.
course, that is one of the ways we try and fight, fraud like that. Is
Yeah,
by
yeah.
limiting kind of the number of nodes you could be fraudulent with.
Right. And if I'm running a website that works with Saturn, I'm presumably directly paying Saturn.
Exactly.
to host it.
Exactly.
Okay,
Exactly.
cool.
Great question.
Thank you, Oscar.
Yeah, Colin.
Question about the kind of reward function. So like, is it possible, for example, to receive a request which you can only serve in a way that's going to hurt your score? Like say you receive a request and like you can tell in advance that it's from an IP address that's really far away. So you're going to get a very low latency on the request. But that is a high multiplier in the reward function.
Yeah, so that's an interesting point. So the way that we are implementing the speed performance specifically is such that it's sort of a step function in a way. So what this means is we have a sort of threshold for time to first byte and total download speed. And if you are above that threshold X amount of times, then that will be your sort of performance, your final metric. So it's how many times you are above that minimum threshold. Of course, sometimes you'll be below, and you'll get a smaller reward. But in the end, what we hope is that these will kind of smooth out. If you have a good enough performance, your overall percentage of requests that you are above these thresholds should be high enough.
I guess what I'm thinking about really is like an adversary sort of thing. Like if I were directing requests to someone who couldn't serve them well, like to what extent is that?
But so yeah, it makes sense. But what I'm trying to say is that will only be meaningful to you as a node operator if that will be a big part of your traffic. So if it's just one request in a million, it will barely change the percentage of times you are above the speed performance. And if you are being DDoSed like that, in a way, we will have the fraud detection system that is also looking at the client side, so trying to find like clients that are just calling one specific operator, for instance.
So the improvement of the fraud detection system is sort of predicated on the ability to post hoc or post fact label some of the events that we have as fraudulent or non-fraudulent.
Yeah.
Do you have any ideas on how to do that?
Yeah. So our initial idea is really just to look at the, so first we'll start by, at the moment we have some rules in place, and first is looking at what are those rules flagging, and is this like truly fraud or not. We also have some requests that are being done by trusted nodes, so we can use that to have a sense of the false positive rate, and so we'll get some labels from that as well. But at the moment, it's not a best answer, but you'll have to go to some and actually manually label them and trying to understand is this fraud or not.
What are your thoughts on the privacy properties of this system? As far as I understand, the orchestrator gets the HTTP access log from the L1 nodes, and then also to do your fraud detection, you need the logs from the retrieval clients. Mm-hmm. So the orchestrator would have a pretty much universal overview of what's being retrieved in the network.
Apologize.
So my question is, what your thoughts are on the privacy properties of this system, given that the orchestrator sees everything that's going on in the network?
Yeah, I mean, like, it is a setback at the moment, but like, because the orchestrator does see everything on the network, but we try to implement like some forms of privacy, like as Diego was saying, with like double hashing IPs and stuff like that. But it's something that we're working towards.